We want to keep adding to our list of derivative properties that allow us to find derivatives of functions more quickly. And in this, on this topic, we want to introduce our power rule, which tells us that the derivative of a function f of x, which is equal to x to the nth power, is n times x to the n minus 1. Meaning what we do is take that exponent, drop it down as a factor in front of the variable, and then the exponent, the original value in the exponent, gets subtracted by 1. And we can apply that property, that rule, anytime we have a variable raised to a constant power. For instance, in example 5, we want d over dx of x to the 13th power To find that, we'll bring that original exponent down as a factor in front, and then the original exponent gets reduced by 1, so we get 13x to the 12th. In example 6, we want to find dp over dx, which means the derivative of that function p. Now what we have is x raised to a negative value, but that doesn't change the way the power rule works. We still bring that original value down as a factor in front, and then the original exponent gets reduced by 1. So this will give us negative 8 x to the negative 9th power. Similarly, in example 7, now we have x raised to a fraction, so not just a whole number but some other value, but that doesn't change the way the power rule works. To find dg over dx, we bring that original exponent down as a factor in front, and the original exponent gets reduced by 1, which will give us 1/2 x to the negative 1/2. Or if we wanted to rewrite that with a positive exponent, we could move that x down to the denominator to write this as 1 over 2x to the 1/2 power, which is also the same thing as 1 over 2 times the square root of x. In example 8, we have something that doesn't initially match the power rule, so we have to make a small modification here. The same way we got rid of that negative exponent in the last example, we could introduce one here by rewriting this as x to the negative 7th power. Now our function matches the power rule, so we can find d over dx of x to the negative 7th by again bringing that original exponent down as a factor in front and decreasing the original exponent by 1. In example 9, we have another application of the power rule, but now with a coefficient in front of that variable. What we'll do again is just set that aside and then find the derivative of x to the 7th. So nothing happens to negative 4, but when we differentiate, we bring that original exponent down as a factor in front, reduce the exponent by 1, and then just clean up any algebra or arithmetic that's left over. In this case, we'll take negative 4 times 7 to get negative 28 x to the 6th.